Okay, for today's lesson, you're going to need the sheet that says solving equations with radicals. So we've done a lot of work with radicals, but today we're just going to expand that a little bit and solve some equations where radicals are mixed into it. So first off, if you see a radical, you need to know that I need to isolate that radical symbol to free up whatever variable is located inside. So when I'm looking at this one here, I'm going to do plus 4 to get rid of that piece there to make this radical symbol all alone. So we get 9 is equal to the square root of 1 minus 16m. Okay, now if I want to free up this variable, I need to get that radical symbol off. And to do that, we do its inverse operation. So the inverse operation of a square root is to square something. And if you do things to one side, you also got to do it to the other side. Okay, so 9 squared is 81, and then 1 take away 16m. This piece just drops off because the square root squared means it frees that part up, which is what we wanted. Okay, so now if I just subtract 1 to both sides, we have 80 is equal to negative 16m, and then divide both sides by negative 16, and we get an answer of m equals negative 5. Okay, now up top here it says, remember to check for extraneous solutions. So extraneous solutions in terms of math means it's a solution that looks like it could be true, like it could possibly work, but it really doesn't when you plug things back in. And we're going to check that out right here. So m is equal to negative 5, at least we're thinking so, but we can't be certain until we check it. So I'm going to plug it back in. 1 minus 16, plug in a negative 5 there, and take away 4. Again, the negative 5 came from the m. So 5 is equal to, so square root 1 take away negative 16 times negative 5, well, that's going to be positive 80. So that's really 1 plus 80. So you have the square root of 81, and then take away 4. The square root of 81, we know it can be positive or negative 9. So in this case, I'm just going to use the positive one. 5 equals 9, take away 4. Yeah, that's true. So 5 does equal 5. And that's when I plugged in the negative 5, it made the equation true. So this one is a valid solution. It is not an extraneous one. Okay, number 2. Again, I want to isolate this radical symbol, so I need to get rid of this 3 there, that negative 3. So I'm going to add 3 to both sides. So I get 3 is equal to the square root of 2m plus 27. Okay, so now I'm going to go ahead and square these again to get rid of that radical symbol. So I get 9 again, and then equals 2m plus 27. So if I subtract 27, we get negative 18 is equal to 2m. And then if I divide both sides by 2, we see m does equal negative 9. Okay, now for me to test this, to see if it's extraneous, I just start with the original equation, 0 equals negative 3 plus square root 2 times m plus 27. Okay, so 2 times negative 9 is negative 18. Negative 18 plus 27 is 9. So I still have 0 equals negative 3 plus the square root of 9. 0 then equals negative 3. And then we have the square root of 9. If I just use the positive one, plus 3. Negative 3 plus 3 does equal 0, so that does work. So when I plug in negative 9, yes, it makes it work. So it's not extraneous. Okay, number 3. So I'm going to add 8 to both sides. Cancels. So we have the square root of v plus 2 equals now 4. So we're going to square this side, square that side. Out comes just what was under the radical symbol, v plus 2 equals 16. Okay, subtract 2, and we get v is equal to 14. Again, we can't be certain if that's the correct answer, though, because it might be an extraneous solution. So I'm going to plug that back in. Negative 8 plus the square root. 14 for v plus 2 equals negative 4. Okay, so that's going to be 16. And I have negative 8 plus, so the square root of 16 is just going to be 4 if I'm using the positive one, equals negative 4. Negative 8 plus 4 does equal negative 4, so this works. V is equal to 14. Okay, number 4. If I'm looking at the radical symbol, this one's a little bit different because what's attached to it is this negative 4, and it's attached by multiplication. So the opposite of that would be division. So I'm going to go ahead and divide both sides by negative 4, which cancels there, and you're left with the square root of negative 3 minus 14x equals positive 9. So then we're going to square this to free up what's inside, square the right side as well. So then we get dropping out negative 3 minus 14k is equal to 81. Okay, so we're going to do plus 3. That cancels. If I take negative 14k is equal to 84, and then divide both sides by negative 14. So k is going to equal negative 6. Okay, again, we have to check it out. So negative 4 times the square root, negative 3 minus 14 times negative 6 equals negative 36. Okay, so negative 14 times negative 6 is 84. 84 take away 3 gives you 81. So you have negative 4 times the square root of 81 equals negative 36. Okay, the positive square root of 81 is 9, and negative 4 times 9, well, that's negative 36. So that does work out. So k is equal to negative 6. So far, nothing has been extraneous yet. Okay, moving on. Let's go to number 5. So on number 5, I'm going to go ahead and I'm going to divide both sides by 8. So this cancels. We get 9 is equal to the square root of x plus 7. Okay, so we go ahead and square this, square that. 81 is equal to x plus 7. And if I just subtract 7 to both sides, I'm going to get 74 is equal to x. Okay, if I plug that back in to double check, 8 times the square root of 74 plus 7 should equal 72, like the original equation. 74 plus 7 is 81. And the square root of 81, the positive, is 9. 9 times 8 is 72. So it does work. That one is not extraneous. Number 6, I'm going to start off with, I'm going to square that one because there's nothing else I need to get rid of. So I'm going to come over here and square this. So we have 4 is equal to 2n plus 22. Subtract 22, cancels. 4 take away 22 is negative 18 equals 2n. And divide both sides by 2, cancels there. And we get negative 9 is equal to n. Okay, go back to the original equation. Let's plug it back in. 2 is equal to the square root of 2 times negative 9 plus 22. Okay, so we get negative 18 plus 22 is equal to 2. And that's going to be the square root of 4. I know the square root of 4 does equal 2, so that one also works. Okay, number 7. So on number 7, we have this 4 needs to be moved. So I'm going to move it over here. Okay, so it frees up. You got 6b plus 40 under the radical symbol. But now on the right side, you got b plus 4. Okay, so I'm going to square this to free up like we've been doing before. So out drops that 6b plus 40. However, over here, you got to square the whole thing. So here's where we got to employ FOIL method again. B plus 4 quantity squared. So that's going to give me b squared plus 8b plus 16. Okay, this one is different than all the others because we now have an exponent of a 2 in here. So we have a quadratic. And if you have a quadratic, you guys need to solve it like you guys have done before. You could do quadratic formula, or in probably most of these cases, you can do factoring. And I think factoring would be the easiest. So again, if I want to do that, I need to move everything to one side. So I'm going to subtract 6b and subtract that 40. Come over here, do the same thing. Minus the 6b minus the 40. So that cancels all that out there and leaves you with 0 on the left side. Okay, you have your b squared. 8b take away 6b gives you positive 2b. And then 16 take away 40 gives you negative 24. Okay, so now I'm thinking, what can I break this up to? B times b. So two numbers are multiplied to negative 24, but adds to positive 2. So one has to be a positive, one has to be a negative. I know the larger one is a positive. And it's going to be 6 and negative 4. Okay, now if I want to solve these, remember, if you want to solve, that's whatever you plug into these parentheses to make those equal to 0. So in this case, my b for this one is going to be a negative 6, and then it's going to be a positive 4 because we're doing the zero product property. Again, what do I need to plug in now for b to make that parentheses equal to 0? So I have two answers. And when you have two answers, chances are that's where your excluded values are going to come from. So you need to go ahead and test those. So I'm going to plug in first this negative 6. So I'm going to use the original equation, 6b, so 6 times negative 6 plus 40, take away 4 equals b again, so we're saying negative 6. Okay, so 6 times negative 6, well, that's negative 36. Negative 36 plus 40, well, that's going to be 4. So the square root of 4 minus 4 equals negative 6. And again, when we are doing these, we are only worried about the positive root that comes out of here. So the positive root of 4 is 2. And 2 take away 4, that is not negative 6. So negative 6 is an excluded value. Okay, let's try it when we plug in 4. So if I do 6 times b, so we're thinking it's 4, plus 40, take away 4, equals b, 4. So that's 24. So 24 plus 40 gives you the square root of 64. Okay, so square root of 64 plus 40, take away 4 equals 4. Okay, wait, hold up, I screwed up. Yeah, I did that 24 plus 40 right there. I forgot. So that's just the square root of 64. My fault. Okay, square root of 64. We use just the positive root, 8. 8 take away 4 is 4. So that means that one works, but negative 6 did not. So that means my only answer for that one is 4. Negative 6 is an excluded value. Okay, one more together. That's number 8. So we're going to subtract 5. Cancels. So we get the square root of 3a plus 12 equals 6. All right, so we're going to square both of these. Out comes one of them. Right here, 3a plus 12 equals 6 squared is 36. Okay, now we're going to subtract 12. And we get 3a is equal to 24. And then last, we divide both sides by 3. And you get an answer of a is equal to 8. Okay, so check this one out, see if it works. Square root 3a, so 3 times 8 plus 12, and then plus 5 equals 11. So that's 24. 24 plus 12, well, that's 36. Plus 5 equals 11. Square root of 36 is 6. Plus 5, that does equal 11, so A is equal to 8. Okay, be careful when you're going through these. I know we only had one example where it was a quadratic, but again, when you get two answers, chances are pretty likely one of them might be an excluded value. So you got to plug them back in and check that out, okay? All right, go ahead now and do number 9, number 10, number 11, 12, 13, 14, 15, 16, 17, and 18.